and welcome back to our channel where we explore the exciting world of organic chemistry. Today we have a fascinating topic to delve into: the IUPAC naming of aliphatic compounds containing one functional group. You know, the aliphatic compounds are organic compounds in which carbon atoms are arranged in straight chains or branched chains. In this video, we will be focusing on organic compounds that contain a single functional group. So whether you are a student studying for an exam or a curious mind to expand your knowledge, join us on this educational journey as we unravel the intricacies of IUPAC naming for organic compounds containing one functional group. Let us start with a recap of the IUPAC naming structure for organic compounds. The IUPAC naming of organic compound consists of three parts, namely root word. The root word represents the largest continuous carbon chain known as parent chain. It provides the basic name for the compound. Next, prefix. The prefix is used to indicate the presence of substituents or functional groups in the molecule. Next, suffix. The suffix indicates the type of functional group present in the compound. It is added after the root word and reflects the functional group's nature. Prefix again has two parts, primary prefix and secondary prefix. Root word represents the continuous longest chain of carbon atoms. Suffix also has two parts, primary suffix and secondary suffix. On whole, there are 11 parts in the IUPAC naming structure. The first one is number, numerical designation, secondary grade functional groups, that is substituents. Actually, these are called primary prefix, number of carbon atoms, number, numerical designation, nature of saturation, number, numerical designation, and functional group. Let us explore one by one. First, see here, number. It is also called as number prefix. This tells about which carbon atom of the compound the secondary prefix says. Otherwise, substituents or secondary functional groups are attached to. Okay, so numbers are 1, 2, 3, etc. Next, numerical designation. It is also called numerical prefix. When the same substituent or functional group, secondary grade functional group, is repeated twice, thrice, etc., are denoted by di, tri, tetra, etc. Okay. Next, secondary prefix is nothing but substituents or secondary grade functional groups. This tells about the secondary grade functional groups known as substituents. For example, halogens, alkyl groups, alkoxy groups, etc. You see here, halides, fluoro, chloro, bromo, iodo. These are the substituents. Next, alkyl groups, methyl, ethyl, propyl, butyl, pentyl, like that. These are the substituents. Okay, secondary prefixes otherwise. Next, secondary functional groups. Okay, NO2, nitro, NO, nitroso, alkoxy, hydroxy, like this. These are the secondary grade functional groups. Okay, in case of polyfunctional groups, only one functional group will be selected as the primary functional group, and the remaining ones will be treated as the secondary grade functional groups, and they will be represented as substituents, otherwise secondary prefixes. You will learn all those things in the next coming videos. Next, primary prefix. It is nothing but cyclo, and it is useful only for cyclic compounds. If the compounds are not cyclic, this part of the name can be ignored. Next, Continuous longest carbon chain, number of carbon atoms you see here, depending upon the number of carbon atoms present in the longest chain of carbon atoms, root word is named. If only one carbon atom is there, it is meth. If the longest chain of carbon atoms contain two carbon atoms, then it is eth. If 3 carbon atoms are there in the chain, it is prop, 4 but, 5 pent, like this. Okay. Next, again here number. Coming to the primary suffix, number. Primary suffix is again divided into 3 parts: number, numerical designation, and nature of saturation. You see here number. Numbers are nothing but 1, 2, 3. Here number, that is number prefix, tells about to which carbon atom of the compound the double or triple bonds are attached. Next, numerical designation: di, tri, tetra. Numerical designations are nothing but here numerical prefixes when the same double or triple bonds are repeated twice, thrice, 4 times, etc., are denoted by di, tri, tetra, etc. Okay. Next, nature of saturation. This tells about the saturation of the carbon compound. If only single bonds are there, carbon carbon single bonds are there, at that time the nature of saturation is N. If at least one double bond is there in the longest chain of carbon atoms, it is in. Triple bonds are there, it is ein, like this. Next, secondary suffix also has been divided into 3 categories: number, numerical designation, and functional group. Numbers are similar to these numbers only. Here numbers are nothing but 1, 2, 3. Number here represents the, it tells about the carbon atoms to which functional groups are attached. The number of the carbon atom to which the functional group is attached. Next, numerical designation. When the same functional group is repeated twice, thrice, etc., are denoted by numerical designation di, tri, tetra, etc. Next, functional group, secondary suffix. This tells about the functional group with the particular term. See here, these are the functional groups. If only carbon and hydrogen atoms are there in that compound, the secondary suffix is E. When OH functional group is there, it is alcohol, OL. CHO is there, it is aldehyde, all, like this. So functional groups are specific atoms or group of atoms that are responsible for the chemical properties and reactivity of organic compounds. Okay, so this is a brief description about the IUPAC naming structure. I already covered this in my first video. However, I am just reminding once again. Okay. Now let us explore the functional groups or secondary suffixes. Here, suffixes added after the primary suffix to indicate the presence of a particular functional group in the carbon chain are known as secondary suffixes. Here I am going to provide you some functional groups, their structures, and their IUPAC suffixes. Name of the functional group, secondary suffix. Alcohol. The name of the functional group here is alcohol. Its structure is OH. Secondary suffix IUPAC, secondary suffix is ol. Aldehyde, CHO, secondary suffix is Al, all. Ketone, the structure of ketone, functional group is CO. Here there is a double bond between carbon and oxygen atoms. Okay, and here this carbon is attached to other carbon atoms, maybe alkyl groups. Okay, next here the name of this secondary suffix is -one. Carboxylic acid, its structure is COOH, secondary suffix is oic acid. Sulfonic, SO3H, sulfonic acid, amine functional group, its structure is NH2, secondary suffix is amine. Thioalcohol, SH, thiol, cyanide, CN, nitrile, ester, COOR, secondary suffix is O8, amide, CONH2, secondary suffix is amide, acid halide, COX, OL halide. So these are the functional groups and their IUPAC suffixes. I am giving only IUPAC suffixes of these functional groups. Sometimes these functional groups may also be used as the secondary prefixes. At that time, the name of the IUPAC prefix for these functional groups is different. Okay, that you will learn later. Here are the rules for naming aliphatic compounds containing one functional group. The first rule is longest chain rule. The parent carbon chain is so chosen as to include the functional group even if it is not the actual longest continuous chain. Example, see here. This is an organic compound and contains one functional group, that is alcohol functional group OH is there here, and we have to select the longest continuous chain of carbon atom in naming this compound at first, and this one is the actual longest continuous chain. It contains 1, 2, 3, 4, 5, 6. But it doesn't include the functional group. So this is the wrong selection of parent chain. We have to select the longest continuous chain as this because it includes functional group OH. Next rule is numbering of parent chain. The numbering of the parent carbon chain is done in such a way that the carbon linking to functional group gets the lowest number even if there is violation of saturated and unsaturated hydrocarbon rules. Here is an example. So this one is the parent chain we have to select because it includes the functional group OH, and see here I am numbering from left to right and from right to left also. So which way of numbering is the correct one? You see here the numbering of the parent chain is to be done in such a way that the carbon atom which links the functional group should get the lowest possible number. So if numbering is done from right to left, the carbon atom linked to the alcohol functional group gets serial number 1. When the numbering is done from left to right, the carbon atom linked to the functional group OH gets the serial number 6. So right to left numbering is the correct way of numbering, whereas the left to right numbering is the wrong way of numbering. You can see one more example, example 2. For selection of parent chain and numbering it, first we have to select the longest chain of carbon atom in this organic compound, and this compound contains C double bond O, that is ketone group. Ketone group is there, and we have to select the longest chain of carbon atoms in such a way that it includes functional groups and as many as double bonds or triple bonds. Actually, this is the longest chain of carbon atoms. However, if I select this as the longest chain, it doesn't include the double bond. For that reason, I am selecting this as the longest chain of carbon atoms, parent chain. And the numbering can be done in either ways, 1, 2, 3, 4, 5, 6, from right to left also. And which way of the numbering is correct? To know this, we have to look at the functional group. The carbon atom linking to the functional group should get the lowest possible number. If numbering is done, we have to give the numbers to the carbon atoms in the chain in that manner. So left to right is the correct numbering and right to left is the wrong numbering. And one more example you can see here. This is the longest chain of carbon atoms. This one is the parent chain. I am numbering from left to right and from right to left also. Obviously you can see numbering from right to left is the right one, because here OH group, that is a functional group, alcohol functional group, is attached to the second carbon atom if the numbering is done from right to left. From left to right, fifth carbon atom is attached. So numbering from right to left is the correct one, and from left to right is the wrong one. Okay. Rules for chain terminating functional groups such as CHO, COOH, COR, CONH2 and C triple bond N. In an organic compound, if a parent chain is terminated, either any of these functional groups, then the carbon atom in that functional group must be assigned number 1 while numbering that chain. See here, when a chain terminating group such as CHO, COOH, COR, CONH2, C triple bond N, etc. is present as a functional group, it must be assigned number 1. This does not apply to non-terminal groups such as ketone group NH2 and OH, which may or may not be assigned 1. Example you can see here. This is an organic compound contains one functional group, namely COOH, carboxylic acids functional group is there, and we have to select the longest chain of carbon atoms that includes this functional group. So this is the parent chain, and while numbering the parent chain, you have to look for this parent chain because it is terminated one of these functional groups, COOH. At that time, the carbon atom in that functional group must be assigned serial number 1 while numbering that chain. So 1, 2, 3, 4. 4 carbon atoms are there in this. Okay. Naming of this organic compound will be given later in this video only. Here one more example you can see. This is an organic compound. In this, CHO functional group is there, and this CHO functional group is nothing but it is the chain terminating functional group. So at that time, the carbon atom in that functional group must be assigned serial number 1 while numbering the carbon chain. One more example you can see. In this, there is no chain terminating group. OH is the non-terminal group, and non-terminal groups may or may not get serial number 1. So while numbering this carbon chain, we have to number it from right to left so that the carbon atom attached to the functional group OH should get the lowest possible number. 1, 2, 3, 4, 5, 6. Okay. For only chain terminating functional group, the carbon atom must get serial number 1 while numbering the carbon chain. Next rule, the E-dropping rule. dropping of E from primary suffix. Okay, the last E of the primary suffix is dropped when it is followed by the functional group suffix beginning with A, I, O, U, or Y. See here some examples you can see. Alcohols. IUPAC suffix of alcohols, you have known this, it is ol. So alkane, see here. Here we have to drop E. In case of alkane, we have to drop E. Okay. Why? Because this E is following the functional group suffix beginning with O. For that reason, we have to drop E and add OL, alkanol, like this. Another example, carboxylic acids, the IUPAC suffix is oic acid. See here, alkane. Here also E is dropped because this E is followed by the suffix beginning with O here. For that reason, minus E plus oic acid. From alkanes, we have to drop E and add oic acid to this alkanoic acid. Here, alkanol. Next, aldehydes. The IUPAC suffix of aldehydes is Al. Here also we have to drop E from the primary suffix. Why? Because it is followed by the suffix beginning with A. So minus E plus Al, alkanol. Next, ketones. The IUPAC suffix is on. In this case also we have to drop E from alkanes, that is primary suffixes. Okay, so why? Because this E is followed by the secondary suffix beginning with O. For that reason E should be dropped. So minus E plus ONE, alkanone. Next, nitriles. The IUPAC suffix of nitriles is nitrile. Alkane plus nitrile. Alkane nitrile. Here E should not be dropped. Why? Because it is followed by the suffix beginning with N here. E from the primary suffix should be dropped only when it is followed by the suffix beginning with A, I, O, U, or Y. Okay, and in the remaining times we have to retain E as it is. Next, amines. See here, IUPAC suffix is A. Here also we have to drop E from the primary suffix alkane minus E plus amine because it is beginning with suffix A. Okay, so alkane amine. And the fourth rule you can see here, the names of the substituents are prefixed to the parent hydrocarbon according to IUPAC rules with alphabetical order without considering the presence of functional group. And the next one is numerical prefixes di, tri, tetra, etc. are attached before the designations of functional group if two or more identical groups are present. For example, you can see in this organic compound there are two functional group. Same kind of functional groups are attached two times. Okay, so it means we have to use numerical designation for this di. Okay, 1, 2, you can see here the name of this organic compound IUPAC name is butane 1, 2 diol. You can observe one thing here, E from the primary suffix is retained as it is. It hasn't dropped. Why? Because this E is followed by the secondary suffix beginning with D. For that reason E is retained as it is. and 1 2 are the number prefixes, that is the first carbon atom and the second carbon atom are bearing alcohol functional groups. So here OH functional group is repeated twice. For that reason it is diol. Butane 1, 2 diol. Okay. Now let us go for some worked examples here. Problem number 1. This is an organic compound containing OH functional group. We have to provide the IUPAC name for it. Solution. First, we have to select the longest chain of carbon atoms containing the functional group. So this one is the parent chain, and I am numbering the parent chain from left to right and from right to left also. Which way of numbering is correct? Let us see here. Left to right, the locant is 5. That is, if the numbering is done from left to right, fifth carbon atom is attached OH group. From right to left, the locant is 1. That means if numbering is done from right to left, the first carbon atom is attached OH group. So this one is the wrong way of numbering, this one the correct way of numbering. And in this parent chain, 5 carbon atoms are there. The root word is pent, primary suffix only. Carbon single bonds are there in this carbon chain. So primary suffix is ane and secondary suffix OH. Okay, so when OH functional group is there, the secondary suffix is OL, ol. Okay, next, and this one should be taken as the secondary prefix, otherwise substituents. Ethyl C2H5, ethyl group. So the name of this compound is 2-ethyl pentane 1-ol. Here you can observe E has been dropped from the primary suffix because it is followed by the suffix beginning with O. Okay. Next, problem number 2. Solution. First we have to select this one as the longest chain of carbon atoms. This is the parent chain which includes functional group. Okay. And obviously numbering should be done from right to left because the carbon atom attached to the functional group should get the lowest possible number. So for that reason I am giving numbering from right to left. And in this parent chain, 6 carbon atoms are there. The root word is hex, primary suffix is ane. Why? Because only carbon single bonds are there in this parent chain. And secondary suffix, you can see here, OH group is attached to the first carbon atom, alcohol. Okay, so the secondary suffix for the functional group alcohol is ol. Okay, and third carbon atom is attached ethyl group. It is the secondary prefix, otherwise substituent. So the name of this organic compound is 3-ethyl hexane 1-ol. Here also E has been dropped from the primary suffix because it is followed by the suffix beginning with O. Next, third one is this one. Solution. First we have to select the longest chain of carbon atoms in such a way that it includes functional group as well as double or triple bonds are there in that, as many as double or triple bonds. This one is the actual longest chain of carbon atoms. But if I select this as the longest chain of carbon atoms, here functional group is included in this chain, but double bond is not included. After the functional groups, double and triple bonds are given priority while selecting the parent chain. Okay, for that reason I am selecting this as the parent chain. Okay, so see here I am numbering from left to right. Why? Because Here the functional group present in this compound is C double bond O, that is ketone functional group is there, and the carbon atom attached to the functional group should get the lowest possible number. For that reason I have numbered the chain from left to right. And in this parent chain 6 carbon atoms are there. Root word is hex, primary suffix is ene. Why? Because this chain contains a double bond. For that reason carbon carbon double bond is there. For that reason the primary suffix is ene. Secondary suffix you can see here, ketone functional group is there, and the secondary suffix for the ketone functional group is one, O-N-E. Okay, and this one is the substituent or secondary prefix. 1, 2, 3 carbon atoms are there and 7 hydrogen atoms are there. It is propyl group. Okay, the name of this organic compound is, you can see, 4 propyl hexene, hex, 4 propyl hex, 5 ene 2 one. Fifth carbon atom is attached double bond. For that reason 5 ene, and second carbon atom is attached ketone group. For that reason it is one. Okay, 5 ene 2 one. And this primary suffix ene, here e has been dropped because it is followed by the suffix beginning with o. Next, problem number 4, solution. And this one is the parent chain, which includes the functional group OH, alcohol functional group, and the carbon chain, that is the parent chain, is to be numbered from right to left so that the carbon atom attached to the functional group should get the lowest possible number. So for that reason I am numbering from right to left, and in this parent chain 6 carbon atoms are there. The root word is hex, primary suffix is ane. Why? Because it contains only carbon carbon single bonds. The secondary suffix OH functional group, alcohol functional group is there. The secondary suffix is ol, OL. And there are 2 methyl groups, that is substituents, attached to the 5th carbon atom. And the IUPAC name of this organic compound is 5,5 dimethyl hexane 2-ol. Here E has been removed from ANE, that is primary suffix, because it is followed with the suffix beginning with O. Okay. Next, problem number 5, solution. And this is the parent chain, and the functional group present in this is carboxylic acids, COOH. And this functional group is the chain terminating functional group. For that reason the carbon atom in that functional group must be assigned number 1. So this is the parent chain, and 1, 2, 3, 4. Root word, 4 carbon atoms are there in this parent chain. So it is but, primary suffix is an, secondary suffix COOH functional group is there. You can see it is oic acid. Okay. Next, this group C2H5 group attached to the second carbon atom is ethyl group, secondary prefix. So 2-ethyl butanoic acid, 2-ethyl butanoic acid, and here the prefix 1 is not required before the secondary suffix. Why? Because serial number 1 is assigned to the carbon atom in the functional group itself. For that reason, one is not required, one oic acid not required that. So 2-ethyl butanoic acid. Next, problem number 6, solution. In this organic compound also there is a chain terminating functional group CHO, and at that time the carbon atom in that functional group should be assigned number 1. Okay, and the root word is pent because it contains 5 carbon atoms. The primary suffix is en. Why? Because there is a double bond in this chain. Secondary suffix you can see CHO means aldehydes. So the secondary suffix for the functional group aldehyde is Al, all. Okay, and the name of this organic compound is pent-2-enol. Here E from the primary suffix is dropped. Why? Because it is followed by the secondary suffix beginning with A. For that reason 2-enol. Here 2 represents the double bond, the carbon atom to which double bond is attached. So pent-2-enol. Okay, so that's all for this video, and more examples can be seen in the upcoming video. Thank you.